it's common denominator. I'd have to go back and look at our old notes, which I can if you would like to remember. If you need these other ones.
I think that's good enough.
Right, I was going to do the next one under level 5, unless you tell me otherwise.
You can do that.
Okay. All right. So again, I'm going to work on the left because it's the worst. And then again, just to kind of like make this more manageable, tangent is sine over cosine. So instead of the 1, I'm going to write cosine theta over cosine theta instead of that 1 there on the left. And that really, just saves you time here. Same thing with the 1 in the middle. Cosine theta over sine theta. So I'm going to do a sine theta over sine theta like that. And actually, I should do a bit more here. I should change cotangent into cosine over sine. And then tangent into sine over cosine. That would be better. That would be even better.
Okay.
Any questions on anything so far? Because now we're kind of on to the heavy stuff. So the bottom becomes the common denominator, right? It becomes cosine theta minus sine theta over cosine theta. But really in the same light here, what we want to do is we want to multiply by cosine theta over 1. Cosine theta over 1. And the reason is we really want to get that cosine theta out of the bottom there. So what this produces, and we're going to do the same thing on the right, is cosine squared theta over sine theta over cosine theta minus sine theta, like that. Let me know if there's anything unclear about that.
How come it didn't become cosine squared theta minus sine theta on the bottom?
Because you're gonna cancel. You're canceling these right there. With the
Oh,
red.
okay.
Yeah, it could, but then you've not gotten any further on this. And I don't know, I feel like this is different than we did it before, so hopefully this is going to work out. The one on the right here, we're going to do the same thing. It's sine theta minus cosine theta over sine theta. And then we're going to multiply the top and bottom by the sine theta. So just like you mentioned there, those are going to cancel the sine thetas, and then you got sine squared theta over cosine theta over sine theta minus cosine theta with a plus Still a plus in the middle. Is that okay so far?
Yeah.
All right. Now, one of the things I'm noticing is the bottoms are really similar, except they're off by a sign. So if I factor out a negative, like from the one on the right, this becomes cosine theta minus sine theta now, instead of the sine theta minus cosine theta. And that negative is going to go right in the middle. So it's going to be cosine squared theta sine theta over cosine theta minus sine theta, sine squared theta over cosine theta minus sine theta. And now we have a common denominator of cosine theta minus sine theta. And then it's cosine squared theta over sine theta minus sine squared theta over cosine theta. So we really need to make a common denominator in the numerator. So to do that, we're going to multiply them by the opposite one. So cosine theta, sine theta. And that leaves you with cosine cubed theta minus sine cubed theta over sine theta cosine theta, like this, all over cosine theta minus sine theta. So we're gonna get rid of these fractions here by multiplying the top and bottom by 1 over cosine theta minus sine theta. And so our next line, fine, we're getting really close. I know maybe it doesn't seem like it, but we're really close here. Cosine cubed theta minus sine cubed theta over sine theta cosine theta times cosine theta minus sine theta. And you may feel like, well, we're not even close, but we really are. We're really close here. So the numerator is difference of cubes, and I'll write that formula off to the right here. So what that becomes is cosine theta minus sine theta. This is the numerator. Cosine squared theta plus cosine theta sine theta plus sine squared theta. That's all the numerator. Sine theta cosine theta minus sine theta. And you do get the cancellations here now. You get that this one cancels with this, top and bottom. And then I'll highlight the part that becomes 1. So you get that and that. Is that okay?
Yeah.
All right. So now it becomes 1 plus cosine theta sine theta. And then we're going to divide each of these by the sine theta cosine theta. So I believe your instructor made a mistake when he, nope, I guess maybe not. Sine theta cosine theta. Yeah, I think the teacher's missing a 1 on this, on the one on the right. Because it does become secant theta cosecant theta on the left here, but it's plus 1. Happy to go look at that. Let me actually graph it. Be the faster way to do it here. Yeah, I don't like that it didn't work out very nice. Yeah, so your teacher did leave out a +1 on the answer on the problem. So just to be clear, maybe it's not clear. I checked this with the graph, but this should have been +1.
Yeah.
Maybe you can bring that up. I would send an email, maybe get some bonus points for that.
Yeah, I should probably tell him, especially if it's on the test.
Yeah, this one's horrible. This one's really bad. Okay, what should we do from here? I don't think we've done the third level 5. And I don't even remember that being in your
No.
book, by the way, but we can certainly,
Yeah, we can try that one.
okay. You're into pain and suffering is what I'm hearing. This is horrible.
Well, these are the absolute hardest. This is probably
Yeah,
gonna be like one of them.
yeah. All right, so we're gonna work on the left side. The teacher's trying really hard to point out what to do, and it's to multiply by the conjugate of the bottom, which may not make a ton of sense here until I show you what that actually means. But this thing in parentheses, you're supposed to treat it like it's a term. So this is cosine theta minus sine theta minus 1, I believe is what the intent here is. Is that okay?
Yeah.
All right. So the bottom becomes cosine squared minus parentheses sine theta minus 1 squared, like that. That's the bottom. Actually, we'll put that on the bottom. The top becomes, be careful here how I write this, because the answer is 1 minus cosine theta. I guess that'll come out of that. The top I'm going to FOIL. I'm not sure that's the right path, but it's cosine squared theta. And then it's minus 2 sine theta minus 1 plus sine theta minus 1 squared, like that. That's foiling the top. First outer, inner last. Any questions on that?
Did you FOIL the bottom?
I did. It's difference of squares, so the outer and the inner cancel. Cosine theta times this minus sine theta minus 1 cancels with the cosine theta, sine theta minus 1 plus. So
Okay.
all right, so now in the numerator, I guess I'm gonna do some stuff here. I'm gonna actually like expand. So we have cosine theta minus 2 sine theta plus 2. And then this one on the right here, if you're gonna FOIL it, sine theta minus 1, sine theta minus 1. You want to write it out. Don't try to just square. So it becomes sine squared theta minus 2 sine theta plus 1 over. Same thing for this one on the bottom here, sine. Well, it ends up being exactly the same. So we have cosine squared theta, and then we've got minus sine squared theta plus 2 sine theta minus 1. So it matches these last three terms is just opposite in sign. Okay, so a few good things. The part in green becomes 1. And you've got this other one, that's 2, plus this other 2 is 4. So it's 4 minus 2 sine theta. No, 4 minus 4 sine theta, sorry, 4 minus 4 sine theta. Because you got 2 sine thetas, and then 4. 2, yeah, the 1 does, yeah, so that's that. And then on the bottom doesn't look great. Yeah, this is not good. So the top though does factor. I'll just do that over here. 1 minus sine theta, like that. That's pretty good. The bottom here, let me go back to what did we have as the beginning? 1 minus cosine theta. So I'm looking at an identity here for one of these. So let me turn cosine squared into 1 minus sine squared theta, like that. Minus sine squared theta plus 2 sine theta minus 1. So that's using the Pythagorean identity for this cosine squared theta. And I'm fully guessing. I really don't know if any of these work. But what I do see now is that the red, the ones cancel. That's good. And so we did get something good out of this. We've got 2 sine theta minus 2 sine squared theta. And that means we can factor out a 2 from both of these. So sine theta, I'm sorry, we can factor out a 2 sine theta from both. Sorry. This is just the bottom. 2 sine theta from both. 1 minus sine theta. So this is really good. This is going to go into the bottom over here. This is actually going to turn out. And you can see that these cancel. Let me grab this. Really hope I didn't make a mistake. So this becomes 2 over sine theta, which is not even close to the original, but let me do some graphing here. See if I can make some sense of this. All right, I think I made a mistake somewhere. This one isn't working out very nicely. Okay, so I made a mistake somewhere. I gotta have to backtrack here a little bit to find it. All right, really sorry. Let me just check here. Cosine theta minus sine theta. Okay, so the numerator cosine squared. And we got 2 of those. Minus 2 sine theta plus 2. And then we've got plus that one. Sine squared theta minus 2 sine theta plus 1. Okay, that's looking good. The bottom, these differences squared, so it becomes this squared minus this squared, which is what we have, minus sine squared. Okay, that looks okay. So that's 1 plus the 1, that's 2, that's 4. 4 minus 4 sine theta. Got those 2 right there. Bottom, 1 minus sine squared theta minus sine squared theta. plus 2 sine theta, 2 sine theta minus 2 sine squared theta, 2 sine theta times 1 minus sine theta. So the original identity works, but what I got, obviously, this does not work. I'm still not able to find my mistake. 2 sine theta, 1 minus sine theta. Did you notice anything? Sometimes I don't.
No, I mean, everything kind of just worked out, right?
Yeah, that's but I've got the two graphs up and they are the same. We just double check that those are the right graphs. Yep. I feel like the mistake came earlier. How much time do you want me to spend looking for it? I mean, I probably will find it in the next minute or two, but I don't want to waste your lesson time finding my own mistakes.
I mean, you can find it.
Okay, give me just a moment here to really get through this. All right. So I don't have a good answer. So what I'm gonna do is I'll work this out later and send you a picture of it. Figure out
Okay, you
what's
can
going
do
on.
that.
Figure out what's going on with that. So I do apologize. I would be tempted to redo it and work on a little more of the right side, but we don't want to spend all this time on this. So let's not do that. Okay, level fours. Just start at the top. Any of them?
Yeah.
Okay. So one of the things that I've been doing along the way is I've been graphing these to make sure that the left actually equals the right. You may consider doing that as you're studying just to confirm these actually are equal. So, but kind of a mess here again. I'm going to FOIL the numerator. So this, this is secant theta minus tangent theta, secant theta minus tangent theta. I'm going to FOIL that. So that's secant squared minus 2 secant theta tangent theta plus tangent squared theta plus 1. And then on the bottom here, I noticed that they both have a cosecant. So I'm just going to factor that out for the moment. Okay, secant theta minus tangent theta. Now in the numerator, I'm going to use an identity. So since my answer has tangent in it, I'm really tempted to use 1 plus tangent squared theta equals secant squared theta. So I'm really tempted to use this. Just trying to look ahead here to see if that works out nicely. So there is, but there's also another possibility here. See how there's already a 1 plus tangent squared in here. So this could be secant squared theta. So I'm sort of hemming and hawing a little bit. on that. So actually, let me do that. So that becomes secant squared theta minus 2 secant theta tangent theta plus secant squared theta. So that is 2 secant squared thetas in the numerator. So your numerator becomes 2 secant squared theta minus 2 secant theta tangent theta. And then cosecant theta minus tangent theta. So I noticed that you can factor out a secant, 2 secant theta in the top. So we got 2 secant theta times secant theta minus tangent theta. Oh, that's good. See how that worked out nicely? Because we have a secant theta minus tangent theta on the bottom, cosecant theta here. So the good news is those cancel, and really close here. Secant is 1 over cosine theta. Cosecant is 1 over sine theta. So if you multiply by the reciprocals, sine theta over 1, sine theta over 1, you get what you're looking for, which is 2 sine theta over cosine theta. And that is the 2 tangent theta that you're looking for.
But what exactly did you do for the second step?
Where tell me where. This line.
So yeah,
So I factored out cosecant theta from the bottom. The top I just foiled, multiplied secant theta minus tangent theta times secant theta minus tangent theta.
oh, okay. So secant squared minus 2 secant. So you want to FOIL when you see it, like, for example, secant theta minus tangent theta, the second power.
Yes, almost
Okay.
always. Okay, we can move on to level 4, number 2. All right, so small error. I guess this is probably a cotangent. P is near T on the keyboard, so it's probably cotangent. We're gonna work on the left side. We're gonna make a common denominator on the left. So we're gonna multiply both by their conjugates. Like that. And that will give us a common denominator, which is really nice. Really, really nice here. Right. So I'm not going to multiply the numerators. The bottom, though, becomes 1 minus cosine squared theta. That's when you FOIL, that's difference of squares. And I know it's hard to know, when do you FOIL, or when do you multiply, when do you look for difference of squares? You know, just the more problems you do, you know, the better you get at this. There's just not a great answer for you, but and with the top, you might, well, why am I not multiplying in? Well, I'm looking ahead. I know that 1 minus cosine squared theta is really sine squared theta. And I see right away, oh, that cancels with sine. And I know that tangent is sine over cosine, so it will also cancel.
How come you didn't multiply the top immediately?
Because I was looking ahead. I could see that this becomes sine squared theta on the bottom. And it's going to cancel with that sine, and I'm going to be able to cancel it with the tangent also.
Oh, okay.
It's a good question because like you normally do, but there's an awareness of what's around the corner. So we got sine theta over cosine theta for tangent, plus sine theta 1 plus cosine theta. This is the top still. Now the bottom is really sine squared theta, but we want to divide each of these by that now. And so like what's going to happen here is this sine cancels with that one, and this sine cancels with one of these. So there's a lot going on here. These aren't, some of them are fast, some are not. The now I'm going to multiply 1 over cosine theta, 1 minus cosine theta, and this is all over sine theta, plus 1 plus cosine theta over sine theta. We're going to start to see some of the answer here. Okay, so I think, I'm hoping. The so on the right here, it's 1 over sine theta plus cosine theta over sine theta. So the good news is that is your cosecant theta plus your cotangent theta, and we need some of that. On the right, it's a little harder. It's 1 over cosine theta minus cosine theta over cosine theta, multiplying the top all over sine theta. And you just kind of gotta look ahead here a little bit. So the top becomes secant theta. I'm sorry, let me not do that. Let me multiply the top and bottom by 1 over sine theta. That'll probably make more sense here. So this becomes 1 over cosine theta sine theta minus, those cancel, so it's just 1 over sine theta plus the cosecant theta plus cotangent theta. Did I miss no. So this becomes minus cosecant theta. And on the left here, it's 1 over cosine theta times 1 over sine theta. And you can start to see everything's going to fall out and work. Those cancel. 1 over cosine is secant theta. 1 over sine is cosecant theta. And there you have it. Anything you want me to go over again on this one?
No, it's pretty straightforward.
Okay. Should we do the third one under level 4?
Yeah.
Okay. So we're obviously going to work on the left side here. We're going to make a common denominator right away. So instead of the 1, it's going to be sine theta over sine theta, cosine theta over sine theta. Instead of the 1, it's going to be cosine theta over cosine theta, sine theta over cosine theta. We did this in a earlier problem or a couple earlier problems.
Yeah.
So what to do from here? Use the common denominator. So it's going to be sine theta over sine theta minus cosine theta over sine theta. Now, what I want you to do from here is see that we really need to clear out that sine theta. So we're going to multiply the top and bottom by sine theta over 1, and that becomes sine squared theta over sine theta minus cosine theta on the bottom. So on the right, same thing here. It's cosine theta over cosine theta minus sine theta over cosine theta. And then you're going to multiply the top and bottom to get rid of the cosine theta over 1. So that becomes cosine squared theta over cosine theta minus sine theta. So we had this in an earlier problem where the bottoms were mismatched with sine. So you take a negative out of 1. I'm going to suggest the one on the right. So that's going to make the bottom become sine theta minus cosine theta. Okay. And then we're finally ready to combine the fractions. Sine squared theta minus cosine squared theta over sine theta minus cosine theta. The numerator is difference of squares, and that's, you got to kind of peek ahead to see that. That gives you a minus b, a plus b. So you've got here sine theta minus cosine theta in the numerator, which is good because that's going to cancel. Sine theta plus cosine theta all over sine theta minus cosine theta. These cancel, and you're left with just the sine theta cosine theta like you wanted. I'm going to switch to a level 3 just to close out this session. Just do the first level 3 here if that's okay with you.
Yeah, we could definitely do that.
I think it'll fit the time we've got. So this one, probably a both sides situation. Not completely sure, but one of the things I would suggest is like sometimes writing these out like cosine theta minus sine theta over 1 over sine theta, like that, because you kind of start to see what we've got here, which is this is now squared on the right. So this becomes cosine theta minus 1 squared over sine squared theta, because you're squaring the top and the bottom. Is that okay?
Yeah.
All right, so the on the left here, we're going to work on that. So we're going to multiply the top and bottom by the conjugate. So 1 minus cosine theta, 1 minus cosine theta. So on the bottom, you get 1 minus cosine squared theta, and on the top it's 1 minus cosine theta all squared, which looks really similar to what's on the right. So on the left here, this 1 minus cosine squared theta ends up becoming sine squared theta. Okay. right? So this ends up being, let's go 1 minus cosine theta squared over sine squared theta. And on the right, cosine theta minus 1 squared over sine squared theta. So in terms of what to do next, if you square the tops, you will find that they're the same. There's actually a couple ways to do it, like foil the tops. So 1 minus cosine theta, 1 minus cosine theta over sine squared theta, cosine theta minus 1, cosine theta minus 1 over sine squared theta. So the top, when you FOIL the one on the left here, you get 1 minus 2 cosine theta plus cosine squared theta. On the right, you get cosine squared theta minus 2 cosine theta plus 1. And you hopefully notice that they are exactly the same.
So you got that from FOILing?
Yes,
Okay.
yes, they're exactly the same. So what I'd like to do here is take a short break. I just need enough time to make a sandwich real quick and eat. I can come back at either right at 3 or 2:55. I'm just going to keep this call open. Do you want till 3 o'clock or 2:55? What would be best for you?
You could do 3 o'clock.
All right. I'll see you in 10 minutes. You're welcome to exit and rejoin, but I'm going to stay on here. I'm just going to mute myself and check with you at 3 o'clock.
Yeah, I'll just stay on here too.
All right. Thanks. Hey, Jadon, let me know when you're back or ready to go.
I'm back.
All right. So this is the last problem. We're going to go for about 25 minutes. This is the last problem for level 4. I'm sorry. Yes. And we've kind of done a bunch like this, but we're going to do the same thing with this conjugate business here again. So on the left here, it becomes 1 plus cosine theta, 1 plus cosine theta in the top, minus sine theta, cosine theta. And then on the bottom, we've got 1 plus cosine theta, 1 minus cosine theta, 1 minus cosine theta. Now, what I noticed, the reason we're doing this, because each conjugate gets you to a perfect square, difference of squares situation and a common denominator, which is really nice. So like the more that you can see ahead, the better. The more that if you recognize the bottom becomes in both cases 1 minus cosine squared theta. This is the bottom. And if you furthermore recognize that that's really sine squared theta, you're so much further along here when you're doing these problems. Is that okay for the moment?
Yeah.
Okay. So if you're okay with making that leap, the bottoms become sine squared theta, sine theta 1 plus cosine theta. And again, you might say, well, why aren't you multiplying in the numerators? It's a totally fair question to ask. It's because I'm looking ahead to see that I'm going to cancel some stuff before I do that. So on the left here, it's that sign cancels with that sign cancels with that sign. So now it's like, well, what do we even do here? On the left here, I'm going to divide both of them by sine. So it's 1 over sine theta plus cosine theta over sine theta. And on the right, I guess I'm going to make this, so I guess I need to distribute in, which I don't like doing, but I don't see what else to do. So this is cosine theta minus cosine squared theta over sine theta. And then I can divide each of these by sine theta. So this negative here, it's going to go to both. So it becomes minus cosine theta over sine theta plus cosine squared theta over sine theta like that. And then you can start bringing this other stuff down. So notice these middle ones cancel. And so you're left with 1 over sine theta. What is that? That's cosecant theta. I'm doing that because I'm looking ahead to see that the answer has a cosecant theta in it. Snipping that in here. So that's good. And then plus, so it's really cosine theta over just 1 sine theta. And that gives you a cosecant theta. Cotangent theta is what it gives you. Sorry, I was looking ahead and I don't like what I see here. Oh, I know I see what I want. This one is tough. So this is actually not quite right. We want to move this over a little bit and we want to put a 1 here like that. So now it's cosecant theta plus cosecant theta cosine squared theta. And then you can factor out a cosecant theta from both. And that gives you the 1 plus cosine squared theta.
Okay, got it.
Right. Now, the nice thing, I mean, as we move through these, they're going to get a lot faster as you move through them.
Yeah.
So we can keep going through some level 3s here. The other thing that you might get on one of these tests is where you get to pick, they give you the whole test and you just pick, like, do one level 5 and one level 4 and 2 level 3s. Sometimes they do a pick 'em on
Yeah,
this.
he said he's gonna give us like multiple versions of the test, and then he's gonna let us pick which one we want.
Okay. All right, so this one here, I'm looking at the left side because it's a sum. Sum becomes a product much easier. Cotangent is cosine theta over sine theta. Tangent is sine theta over cosine theta. And so what I'm immediately drawn to is common denominator, getting a common denominator between.
Yeah.
And what you might start noticing is that the steps we're doing right here are steps we
So
were
you
doing.
multiply by cosine on the left side of the.
Yes. Cosine squared theta, sine theta, cosine theta, sine squared theta, cosine theta, sine theta. So you combine the tops. So it's cosine squared theta plus sine squared theta. Bottom becomes sine theta, cosine theta. The top does become just 1. And then you split this apart. You probably already got this. Sine theta times 1 over cosine theta, cosecant theta, secant theta, like that. Do the third one here. Unless there's any questions on that.
Yeah, we can do that.
Right, so we're going to work on the left side. Obviously, it's way more complicated. I'm sort of drawn to writing these out as sine and cosine to start. I also kind of look ahead and notice that, I can make a common denominator on the top pretty easily. Bottom isn't that much worse. Like that. But the fact that the numerators combine, cosecant 1 over sine, cotangent is cosine over sine, that's really good. So we'll move through it from here. On the bottom, I want to make the common denominator of cosine theta. So now again, like kind of doing as much as we can and without having to do a bunch of rewriting. The big numerator up here in the top becomes 1 plus cosine theta over sine theta. The bottom is now sine theta plus sine theta cosine theta over cosine theta, like that. This line right here, if you factor out a sine theta, you get 1 plus cosine theta here, which is really important. So I'll rewrite it like that. Go. And from here, you're going to multiply by the reciprocal. And you should notice a cancellation, which is why you're doing this. You're in the top, because the bottom, obviously everything in the bottom all cancels. It's in the top that you get that over that. And I'm looking ahead here. sorry, I didn't look ahead far enough. I'm sorry, I missed a sine theta. There's a sine theta here. I didn't write that. That's why it wasn't working. I was like, why isn't that working? So you're left with cosine theta in the top over sine theta, and we'll put a 1 there. So the cosine theta over sine theta, that's your cotangent theta times your cosecant theta, like that.
We got that.
Anything on there? Okay, put that. Right. Okay, so I'm going to work on the right side here. Looks more complex, at least to start. Then we may have to work on both in this example. So the right is actually a perfect squared trinomial. It's a squared minus 2ab plus b squared. And that always becomes parentheses a minus b squared. So your a is the secant theta and your b is the tangent theta. So that's secant theta minus tangent theta squared. So again, you might wonder, well, why are we even doing that? Well, secant is 1 over cosine theta, tangent is sine theta over cosine theta, and that's a common denominator. So this becomes 1 minus sine theta in the numerator over cosine theta, and then you're squaring it. So the top we'll leave as 1 minus sine theta squared. The bottom is cosine squared theta, which you're supposed to say, oh yeah, that's an identity. Cosine squared theta is 1 minus sine squared theta. So the bottom becomes 1 minus sine squared theta. The top is still 1 minus sine theta squared. And from here, you factor the bottom. The bottom is difference of squares. Let me make a note of that. A squared minus b squared. A minus b, a plus b. So the bottom becomes 1 minus sine theta, 1 plus sine theta. The top is 1 minus sine theta times itself, 1 minus sine theta. And wouldn't you know it, they cancel, leaving you with what you want.
Yeah, they're definitely getting a lot easier.
Yeah. There's also test taking styles where they say like, well, you just need to get to a certain point total. So like, for example, like if you can get up to 30 points, that's an A. You got to do 5, enough problems to get up to that point. Or 20 points or something. It just depends. So let's see here. I guess the next one. Some of these are looking there. Some of them are looking new, but we've done so many. Maybe I'm just forgetting. All right.
Yeah, I think we did this one before. Now that I look at it.
No, but we're happy to do. I'm happy to do. I'm just sort of making comments out loud just to fill the void. At this point, is there any you want me to go through? Because we don't want you to miss out on one if you're like, I have no idea.
I'm trying to find one that looks unfamiliar to me.
I'm sorry, say that again.
I'm trying to find one that looks
Okay.
unfamiliar to me. What about something like the last level 3, the one that's cotangent over 1 plus cosecant and then 1 plus cosecant?
Okay, yeah, so let's look at that. But really, there's two strategies when you're looking at the left side. The one is to make everything sine and cosine. The other is to start multiplying by conjugates. I guess I'm gonna go towards sine and cosine because like multiplying by the conjugate doesn't get you there right away. The cosecant is 1 over sine theta. So the 1 on the left becomes sine theta over sine theta plus. And on the right, cotangent is cosine theta over sine theta. And then the numerator similarly is 1 over sine theta over sine theta. And then some good stuff's going to happen here, I think. So on the left here, cosine theta over sine theta. And then we've got sine theta plus 1 over sine theta. So one of the things I see immediately is that the signs on the bottom cancel. This is big. You know, anytime you can eliminate the fractions, that's good. So this produces cosine theta over sine theta plus 1. Then we'll probably see something similar. Yeah, we'll see exactly the same thing here on the right. We've got sine theta plus 1 over sine theta over cosine theta over sine theta. And again, those bottoms are going to cancel. And in some ways, I mean, this isn't any better than what we started with, but it is sine and cosine, which I guess are a little more familiar with. So sine theta plus 1 over cosine theta. And so the next thing I'm looking at here is I guess we got to make a common denominator, although I really don't like the fact that I'm going to hold off on that. I'm going to multiply the left one by the conjugate. I guess we can't get a 1 minus sine theta. Now, the reason I was drawn to that is I'm looking ahead. The bottom on the left here is going to become 1 minus sine squared theta. And that's really cosine squared theta, which is going to cancel with that cosine theta. So you almost got to like see it to know that, okay, that is the right strategy here. This is 1 minus sine squared theta. And so the bottom is really cosine squared theta. And so now we've got a cancellation. If I can get the right color pen, cancellation. And then now the bottoms are the same. The denominators are finally the same. We got 1 minus sine theta over cosine theta, sine theta plus 1 over cosine theta. Bottoms are now the same. So we got 1 minus sine theta plus sine theta plus 1 over cosine theta. Sines cancel. And you're left with 2 over cosine theta, which is in fact 2 secant theta.
Okay, got it.
All right, probably got time for one more, maybe two, depending on how fast they go, but probably just one. What else is calling out to you here? Or I can also give you sort of guidance on some of them, like some suggestions. That's also another
Yeah,
way to.
you probably should just give me suggestions.
Okay. So we did we do this? Let me see which one we didn't do. Why does that look so weird? Okay, I'll just go up from the bottom since I don't know where we. All right, so this one, I would FOIL and then do the sine and cosine common denominator. And then you may have to do a difference of squares factoring on the left after you're done in this order. But I can, the left looks like it will become, I'm sorry, you don't want to FOIL. You don't want to FOIL. You want to turn the inside into sine and cosine, common denominator, then you square it. We did one just like this earlier. So this will be 1 over cosine theta, sine over cosine theta. You make your common denominator, you square them, and then you're going to use difference of squares and you'll get a cancellation. This one's really identical to, it's like almost the same as what we did here.
Yeah.
It's almost identical to that. All right, next one up. This is awful. So let me snip it in. All right, so we work on the left, and I would use conjugates on the left to make a common denominator. So you're going to multiply the one on the left by 1 plus cosine theta, the one on the right by 1 minus cosine theta, and then you're gonna probably have to FOIL the tops, and then you're going to divide everything by sine squared, because 1 minus cosine squared will become sine squared theta. On that, and you'll get some things will cross out when you do that. I think this one may be the easiest, most intuitive here. You're gonna multiply the left and multiply the right. And you're gonna multiply the right. You're gonna FOIL this. You're going to use at some point the fact that sine squared theta plus cosine squared theta equals 1 to see some things cancel, but you're going to work on both sides, multiply, and you'll get it. All right, this one, I was really debating what to tell you to do here, because there's nothing sort of obvious to me. I might try the sine and cosine stuff on the left, but tangent and cotangent don't really mesh well. On the right, yeah, on the right, tangent squared, secant squared minus 1. This is the one I would need a lot of time to work out, but I guess I would go down the road on the left of sine and cosine, common denominator. And on the right, you might have to use, so tangent is sine squared theta over cosine squared theta over cosine squared theta. 1 over cosine squared theta, so that it actually becomes, the right actually becomes These cancel. It ends up being sine squared theta minus cosine squared theta. So I'm pretty sure on the left, when you do the sine cosine common denominator stuff, you will get, it'll able to get down to something like this on the right. All right, so we're gonna have to stop right